7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
This is the largest anechoic chamber owned and operated by a university in this country. Now I'm the anechoic chamber manager, but I've been here 21 years. It was the neatest thing that we ever worked on. Not a glory hound. I mean, it's not for me, but I could not believe when it took off and everybody was talking about it on the news, nobody mentioned that we did the high gain dish here. But we've been doing tests for NASA, DOD, private companies on satellite dishes, antennas, you name it. But like I said, our part was a long time ago. Not so much me, but Dr. Teh-Hong Lee here helped devise the software to make the perfect dish for him.
It started more than 10 years ago. One of the former students, Ron Schulze, he's responsible for the antenna design for New Horizons. And so basically he took our software and his own software, designed the antennas, and then he designed it and built it and bring it to our lab. They basically lock out themselves in the chamber and do a lot of qualification tests.
Everything had to be timed just right. It's the fastest probe ever to be launched from the Earth. Let's say back in the Apollo days, it took 3 days to get to the moon. This probe hit there in 6 hours. So the timing had to be perfect. They had to go to the moon, around that slingshot to Venus, and then come back. And it's been hitting every other planet since then.
One thing caught my attention is because the spacecraft is spinning while it's traveling in the space, so they need to maintain the accuracy of pointing the antenna to the Earth. It's amazing they can achieve that. And we were also very excited that our measurement facility here can accommodate their need. So it's going to be very exciting and interesting to see what they can find.
They did some very extensive laser setups because that's so important. You could have the most expensive probe in the world, billions of dollars, but if the antenna didn't work right, especially where it is right now, it'd be useless. It'd be just a rock in space. So everything that we test is going to be perfect.